So we're looking at simultaneous equation. Simultaneous equation is just we have two we have two two well a pair we have a pair of equations that has variables in it. It could be any, we could have any variable at all, but at least two variables in it. And the thing is that we actually want to solve this want to solve for the values of these variables. And so for us to actually solve for these variables, we'd have to work these equations at the same time, because the word simultaneous simply means to do more than one things at the same time. So the thing is that before we go, we ensure that we know to solve linear equation. Remember, our linear equation is solved, especially the one that says if we have like x is equal to 4, I want to find the value of x, we'll just divide both sides by 2, and then our answer would be 2. So we'll be looking at and also to substitute, ensure that we know to substitute the numbers in the variables and evaluate the equation or the expression. So we'll be looking at simultaneous equation by using the elimination method. There are more than one methods that we can use, but we're looking at elimination for this video. We'll be looking at another method that is called substitution method, but that method that lesson will be taught in another video. So let's try to solve this pair of simultaneous equation. Now, you can get rid of one of the variables first. So that's what elimination means. Getting rid of one of the variables first, so we can have one variable in the equation. And so when you have one variable in any equation, it is easy to solve for that variable to find out what is the value of it. So seeing that if you have two variables, it is somewhat complicated, or pose some challenge to us. So we want to eliminate one of them, and so we can find the value of one first, and then we'll go and revisit one of the equations and substitute that value into the equation, and so we can actually see what would be the value of both the variables. So let us go. So if you want to get rid of the x or the y, it doesn't matter which one you want to get rid of first. I choose to get rid of the x first. Since I choose to get rid of the x first, then I will take the x's, the coefficient of the x's, and multiply the equations. So what do I mean by that? I would take the coefficient of the x in equation 1 and multiply all the terms in equation 2. And I would take the coefficient of the x in equation 2 to multiply all the terms in equation 1. So let's go and multiply. So we say 4 times everything in equation 1. So 4 times 3x gives us 12x. 2 to 4 times y gives us 4y. 4y, and 4 times that gives us 8. 3 times, so use 3 and multiply all the terms in equation 2. 3 times 12, that gives us 12. 3 times that gives us 9y, and 3 times 3 gives us 9. And so if you should, so if we look, let us go back. So we have equation 1. This is equation 1. 4 equations we have now. So we have equation 1, equation 2, we have now equation 3, and also we have equation 4. So we will stop at 4 equations at the end of the day. So we will look, so what we're going to let us examine the two new equations, equation 3 and equation 4. So look at them. We are seeing two identical like terms in the equation. So if we can subtract them, then we can actually get rid of one and have just the y by itself. Not the y by itself, but the y variable left in the equation. So what we can actually do is to subtract these. We could subtract equation, since these are two equations, so we could say this is equation 3, this is equation 4. Two is we can actually subtract equation 4 from equation 3, and so we could actually get rid of the y term, so the x term. So what we could do, we could rewrite these equations in like terms of subtraction. So we could actually write it like, you could say 12x minus 12x, and we say plus 9y minus 12y equal to, let's say, 3 minus 4. Oh, it's not. Let us go back to the y's. So we have 4y. 4y. See, minus, and we say, oh yeah. So we have 9 minus 8. So let's go. So what we do now, we just actually simplify this. So these two will cancel out, and then what we will have, we have 5y minus, let's say, 1. And so we'll be left with, so to find the value of y, so we have one value, one variable in the equation, which is so comfortable and familiar to us. So we just divide both sides by 5. And so y would be equal to 1 over 5. And so what we could do, we could go to any one of these equations, equation 1, 2, 3 or 4, and substitute the value of y into one of them and just find the value of x. So I know I want to tell my students to use equation that look the easiest one, the simplified one. So I could use equation 1, which is 3x plus y equal to 2. So I'm going to write this down here, and I say 3x plus y is equal to 2. So since y is equal to 1 over 5, we just substitute the value of y into this equation. So we have 3x plus 1 over 5 is equal to 2. And so we could actually subtract both sides by, since it's a positive fraction, we could actually subtract both sides by 1/5. So we could say minus 1/5 minus 1/5. That cancels right there. And so we'll have 3x is equal to 2 minus 5. And so we could actually do the LCM thing to actually get rid of the fraction on that side. Or we could actually multiply this fraction by 5 so the denominators can be the same. So we could actually say multiply both this fraction by 5 times 5. Let's use a different color. 5, this times by 5, and that times by 5. And so we'll have 3x is equal to 10 over 5 minus 1 over 5. Because we learned that in the previous video, we actually work in fractions. So let's just look at this now. So look at now, 3x is what now? What do we get for this now? We have 10 over, well, 9. 9 is equal to 9. So we have 9 over 5. And if to find the value of x, we could do this both ways. We could actually say we could actually divide both sides by 3. Or we could actually do a thing like this. We could say we could reciprocate this. We could say this is equal to that. We could say, no, not equal to that. We could say that times that, or we could do the same thing. That times that. And so this will cancel that. X will be equal to 9 over 5 times 1/3. So we could actually cancel over this side of the fraction, which is 9. Well, this in this goes 1 time, this in this goes 3 times. So what we'll have 3 over 5 for x. Or we could actually prove if this is right. We could actually plug the values of x and y in any one of the equations to see if it is actually true. So I could choose even equation 1 again to prove if when I work toward is actually 2. So I could say, let's look at it. What's the value of x? The value of x is 5 over 2, 3 over 5, and y is actually 1 over 5. So let us look at it. So looking at equation 2, equation 1, where is equation 1? Equation 1. Let's look at equation 1. So equation 1 is actually 3x plus y is equal to 2. So we're going to use that equation to prove if our values are correct. So let's go. So we could say the value of x is 3 over 5 plus 1 over 5. So we should see if this is actually equal to, if this actually equals to 2. Because it actually says it is equal to 2. So just say no, it doesn't work this out. So we say 3 times that gives us 9 over 5 plus 1 over 5. Now if you look at, since the denominators are the same, we can bring back one of the denominators and add the numerators. And so 5 into 10 goes 2 times. So we actually proved that this is actually correct. Let's do another one, a very simpler one than this. So say we have so we have say we have 3x minus y is equal to 10 times 2x plus y is equal to 5. So this time I want to get rid of the y's first. I will actually just use the coefficients of the y's. But what are the coefficients of the y's? The coefficients of the y's are 1. The coefficients of the y's are 1. If you look at it carefully. Well, not 1. One is negative 1 and 1 is positive 1. So we use the coefficient of those to multiply. So we say now we'll actually use the positive 1 to multiply equation 1 and negative 1 to multiply that equation. So let's go. So if I should multiply 1 by negative 1, I'll get back the same fraction. 3x minus y equal to 10. And if I use negative 1 and multiply equation 2, all the terms will be negative. Because negative times, we have 3 positives and we are multiplying by 1 negative. So everything will be a negative. So we have negative 2 x negative y plus, well, equal to negative 1. And so if you look at the equation, we have 2 identical terms in it, which is a negative y and negative y. So we could actually add these negative y's to get them to be eliminated. So if we should add both, what we could actually say now, we could add equation 3 with equation 4. So it all depends on what sign we have right here. That actually tell us how we'd actually work these. So let's go. So I will say then I'll add them. So we add so we say 3x plus minus 2x. We know that that's the back. So we have minus y plus, oh, sorry, we won't be adding them, we'll be subtracting them. Because if we subtract them, they will cancel out. Because look what will happen if we cancel, if we subtract them. If we subtract equation 2 from equation 3 from equation 4, we'll actually eliminate the y's, not adding them. That was a genuine mistake. Alright, so let's look at it. So we subtract equation 3 from it. So we have negative 3 minus 2x. And then we have negative y minus y. And so we actually have 2 negatives clashing. And then we say 10 minus 5. And so we just evaluate, we just simplify. So we say these 2 negatives are clashing, it becomes a positive. So we have 2, these 2 are now eliminated because these 2 negatives becomes a positive, and if you have a negative y plus a positive y, that gives you 0. And so we actually, these 2 become a positive as well. So we will have what we have here, we have equal to 15. And so we just simplify the equation. So we have, this gives us 5x equal to 15. And so we will divide both sides by 5. And so our answer will be x will actually equal to 3. So x is equal to 3. And so since we find the value of 3, we could actually use any one of these equations to find the value of y. So I choose to use equation 2, which is this one, to find the value of y. Somewhat, run from the negatives, because sometimes negatives can pose a challenge to us. So equation 2 says 2x plus y is equal to 5. And so let us prove. So say 2x plus y is equal to 5. Now since x is what? X is 3, so we substitute the value of 3 in the equation. Where anywhere we see x and we evaluate. So this gives us 6 plus y is equal to 5. And so if we want to find y, now we have to subtract both sides by 6. And so y would be equal to negative 1. We could actually prove if it is correct. If x is 3 and y is negative 1, let's prove. Let us use one of the equations to see if this is true. We could even let's use another equation, not the one that we use to solve for x. That's solve for y. So we could use let us use equation 1 to prove if this is correct. So if x is equal to 3 minus y, which is 1, let us see if it actually equals to 10. This gives us 9, and a positive multiplied by a positive multiplied by a negative multiplied by a negative. Or when two negatives are clashing, it becomes a positive plus 1, and that is actually equal to 10. So we prove by using the elimination method. So let us recap. What we do, if you want to get rid of the x variable first, we actually use the coefficients of the x's to multiply the equations. If you want to get rid of the y's first, you use the coefficient of the y's to multiply the equation. And then we should, after once we see identical like terms, then we try to eliminate them by adding or subtracting them. So we could also subtract equation 1, equation 4 from equation 3, or probably we could actually add equation 3 with equation 1. So based on what you see and what you think is a method that you can actually eliminate, then we do that. And then we group like terms, simplify, find the value of one of the variables. And when you find the value of that variable, then we go to any one of the equations and substitute it into that equation and just evaluate you solve for the one that is unknown, and that's it. You can also evaluate your equation to see if the y value and the x value are actually accurate.